All right. Hello, everybody, and welcome to the April 30th, 2025 iteration of the Hyperlight biweekly community meeting. Um, this meeting is being recorded and will be uploaded to YouTube, so just be aware of that if you're not comfortable, it's fine to stay muted, stay off, and everything. All right, I think we can get started. So, yep, just a reminder for everybody, if you could add your name to the agenda. Let me drop a link to the agenda in the chat, though I'm guessing most folks got here from a link in the agenda. But if anybody needs it, yep, just drop it in the chat. A couple of announcements. One is we have another WASM component, like WASM component model component example that got published. We could go over that a little bit later if people are interested. Um, Also, we're expecting to do the v0.4.0 release of the Hyperlight crate today, or the main Hyperlight repository today. I think, Ludwig, I think you were going to drive that. Do you have anything to add to that, or?
No, I was planning on making the release today. Um, I know, Dan, you have a PR out. Do you think you want to get that PR in? Because then we could probably do the release tomorrow or something instead.
The memory factor? No, it won't be merged tomorrow.
Okay,
Yeah, so you
then
can go first with the release.
sounds good.
Do you want to cover
I,
what are the main things in this release, Ludwig? I know you had the updated tracing
Sure.
with the
Let
some
me
more
s-
tests.
let me remind myself what it was. Uh, Once again. Okay, so there's one fix for like a race condition we had where for some reason the hypervisor thread thought it finished the work, but in reality, like it never even started. And then also another change is we're using the metrics crate to emit metrics now instead of using what we were using before. So it should be very easy to just plug in your own metrics exporter and everything should hopefully work. Um, yeah, I think those are the big ones.
okay, I'm just looking through everything. Yep, and a lot of dependabot bumps and things like that too. So,
Yeah,
yep,
Yeah, that guest logging one you just scrolled over, I basically fixed guest logging so that it um, effectively aligns with the host. The situation previously was that the guest could be logging at a much higher verbosity than the host and sending stuff to the host that the host immediately ignored.
it dropped it.
Um, so now uh, that should not happen. And if I recall correctly, there's a method in the guest now where you can actually explicitly set the logging level for the guest. Um,
This max guest level.
Possibly. Can't
Yeah,
remember. Been on holiday since then.
it's all right. Yeah, set max guest log level.
Yeah, that's the one.
Okay. Um, Anybody have anything else to call out for the release? And then after this, are we going to do the I guess like the crates from the other repositories like Hyperlight Wasm follow up, or do we have more things we want to get into those crates?
Well, at least some of this change will be a breaking change for Hyperlight WASM because of the metrics thing.
Hmm.
Um, so
yeah,
we'll need a little bit of time to do that, I
that
guess,
should be
unless
done
Ludwig's
already.
already done it.
Yeah, I've done it already.
Okay.
Okay, that's good.
Okay, I'll take a look at Hyperlight was and see if I can do that one as well.
Like our release for that one, following up on
Yeah,
crates.
Yeah, we still have the PR for the component stuff that Hyperlight WASM is dependent upon, so maybe that'll get in the way somehow.
oh, okay. You're right.
Yeah. Well, there's still component changes that need to go into core Hyperlight crates too, right? Yeah. So I'm guessing those will hopefully all come in the next release, in the May release. Yep. All right, so who wants to discuss some things, or should I go over the like just some of the changes with or the component demo? Really up to you guys.
Yeah, go for it.
Yeah, I'd like to
Um,
see it too, Mark.
okay, yep. I'm not going to not quite set up for demo, but I can kind of just walk through this. So this was something that I put together that was demoing like running a component in the Hyperlight a WASM component with Hyperlight WASM that was more similar to the, like I mentioned here, the calculator example. That's kind of, I think, one of the canonical WASM component like component examples. So in this example, there's a couple components. There's a calculator component that exports a function called eval expression, and then there's different other components that implement different operations. In the Hyperlight, where was it? I guess I'll just go back. In the Hyperlight WASM calculator example, there's a calculator component which is written in Rust, and an adder component which is written in Rust, and a subtractor component which is written in JavaScript, and then a multiply component which is implemented as a Hyperlight host function, and those all get built and composed, and then added into and then executed as a Hyperlight uh, in the Hyperlight guest. Um, so yeah, kind of there's a just file here, which is what we use for building everything, and there's commands for building the adder component, which is just cargo component build, the subtractor component, which is an npm call, which I can go into, and then a calculator and then we build a calculator component. And kind of the one of the important things here is how we compose the components. So after everything is built, we'll use whack to take the calculator module and plug it with the outputs of the adder and the subtractor module, and then AOT compile it, and then we'll run it. Um, one, I can show the wits too. So the wit that we use to build all the components is similar to the wit in the previous, or in the calculator example. There's a like depending on which component we're building, there's different worlds that we target. The adder, obviously, it exports an add function. The calculator will export an add. It'll export the same calculate interface, which has an eval expression and then the operations that are supported, and we'll import the all of the different operations. After we have the composed component, which is plugged with the adder and the subtractor calculator, where is it? We'll have another WIT that we feed to Hyperlight to generate the bindings. And in this case, we have plugged the add and the subtract interfaces, so those are no longer in the WIT, but we still need to let Hyperlight know that we're expecting an import for the multiply function, and that is what gets implemented as a host function. Uh, the example itself is pretty straightforward, where we'll kind of set up a state for the WASM runtime, build the sandbox, register all of the host functions. We can go into that. Yeah, load the runtime, load our Hyperlight module, get an instance to the component, and then call some functions on it. The interesting thing here is like this is where we fill in the implementation for the expected imported the multiply function. So this was just kind of a pretty streamlined example to do all of that. Hopefully we can add on to it. And then the add and the subtract functionality is all in the kind of bundled in the composed module, or the composed Watson binary that we give it to. So yeah. Does anybody have any questions?
I actually think that example is a little bit clearer in the UDP socket one.
Yeah, I think the UDP socket one is very powerful because it shows how we can like stub out or like implement a lot of the WASI interfaces, which are needed to, I think, do actually interesting workloads. Um, but this one, I think, more demonstrates the kind of how like the simplicity, like for wait, like for building a component that does multiple, like for composing a component and then running a component inside Hyperlight. Yeah, David, go ahead.
First off, very cool, Mark. And I'm curious about the usage of WAC. Um, did you explore a WAC file, or did you was plug just the way to go?
I just I didn't explore using a WAC file. Why is my sorry, my printer just started printing something and I have no idea why. Hopefully it will. Okay. No, more so I was following the trying to like mirror the example here, which I think they go through and just use whack plug to show what's getting plugged and not.
Cool. Yeah, that definitely works. One thing I was thinking about is when you that second world or the second world that you have for generating the bindings for Hyperlight. You added back the import for multiply, right?
Um, Not that it was added back, it's just that it didn't get removed. I think the original
Right.
wit still had
I'm
it.
sorry.
Yeah, so
Yeah.
the original wit still had it. And as we plugged the functionality, so the functionality for add and subtract is in the composed module. It isn't in the calculator world component that we're building, but it is in the composed module.
So if you were to run like was it WASM tools wit whatever to describe the wit for that component. So when that component comes out of the compose after it gets plugged, it runs whack. The component itself has the interface inside of there. So you can actually
For multiply?
extract, well, it'll have the entire world
Mhm.
that that component consists of. Um, I guess what I'm getting at is it'll have the things plugged and those will be fulfilled. And then if you ran like wit and uh, describes the actual component world, you should get what you have written as your world for Hyperlight.
Yes.
And oh, thank you so much, James. I really appreciate that. I always forget exactly what the syntax is. I end up having to look it up or run help a couple times on the tool. Uh, but basically, you should get that interface out. And I guess what I'm getting at is uh, it would be it'd be really neat if Hyperlight, if you went to go generate out whatever the bindings were for Hyperlight and you just pointed at a component as opposed to textual um, wit world.
Yeah. Yeah. I'm sorry. I'm looking. I do have I do have something that I can share.
Oh, cool.
Let me switch my screen share. And we can look at. Yeah, I think that could be an interesting next step. But if we do that, there may be a danger of like I think if we include I could see pros and cons to that. If we do have like a WIT file that we give it a like an explicit WIT file and say this is what I want the guest bindings to be generated off of, it can be a bit more deterministic. Because I did notice like if you do cargo component build without the release profile, it will leak in imports for a lot of the WASI interfaces, which are for I'm guessing for like debugging code where those aren't expected to be plugged when you're doing the release modules. So that could cause some confusion as well, possibly.
That's very interesting. I'm curious. So does that mean that you would only be able to use release modules and you wouldn't be able to use debug modules? Because if so, then that implies also debugging symbols would probably not be there.
Um, I didn't look into it too much. I did end up using WASI-Vert to plug the WASI interfaces for a debug module, but it just added some complexity. I think there were some behaviors that were a little bit strange. Like in order to do the component composition, you had to plug each component before the whack call. Otherwise, the whack call would get confused. And I don't know if that was
Yes.
expected behavior or not. So I think it is possible to do that with at least with WASI-Vert and build a debug mode components. I'm sure that there's probably a lot. I didn't look too much into the different configuration options for cargo component either. So there may be ways to get debug symbols for your component without some of the WASI interfaces.
Yeah, you can also fill them like if you use the WAC file, it has a syntax in there with ellipsis that allows you to apply defaults to um, those interfaces that are broadly known, like the WASI interfaces. Um, yeah, I
Okay.
would love to. I will play around with this. I am very interested. Thank you.
Okay. Yeah, so I mean one path could be I mean, yeah, we do give it the AOT compiled WIT file. Hopefully it's easy to I don't know if the Wasm Tools component WIT will process a AOT compiled file or not, but we may want to investigate building bindings from that file and not needing to define it up front. But yeah. Okay. Does anybody have anything else they want to discuss today? Demo?
Try and demo this mesh prototype thing I have.
Cool.
How long we've got? Maybe is the recording going to stop after like 40 minutes or something?
Yeah.
Yeah, okay. Let's see if we can get this done.
I think we probably have like 15 more minutes.
Okay. So let me share 1 second. What's going on here? No, that's that screen. Oh, I don't know what happened then. Hopefully you can see a PowerPoint deck anyway.
Yeah,
Okay, so a few weeks back, maybe a bit more, I built a prototype of Hyperlight using using a thing called Mesh, which is essentially a it's a crate within the OpenVMM project. It's not published as into Cargo Packages repository, but they have an intention to do that at some point in the future. And what this mesh framework does is gives you a way of decomposing your application into these worker components, and you define messages that you can use to communicate between these components. And the sort of interesting thing about this is at runtime you can decide where you want these components to run in regards to processes. So whether they all run in the same process or whether they all potentially run in different processes. And this is potentially interesting for Hyperlight because right now our hosting model is something like that picture, effectively host code, host functions, and all the sandboxes all run within the confines of a single host process. But with Mesh, we can move to a model something like this, where each sandbox, when it's created, gets created in a new process. Now, when you start thinking about this, it brings up the question of, well, what do we do about host functions, right? Today, the model is that the host function lives inside the host process, and we can continue with that model whereby we effectively share a host function implementation in the host, but each sandbox instance runs in its own process. Or we can have a model that looks something like that, where we have a host process and we effectively spawn a process, and then inside of that process, each one of those sandboxes has its own implementations of the host processes that you want to expose to the sandbox. And in fact, you could have a sort of a hybrid model where you have some host processes in the sandboxes process and some host functions in the sandboxes process and some host functions in the Hyperlight host processes as they are today. I'm going to demonstrate these three options. So effectively what we have today, this outer process mode where we spin up a sandbox for each, we spin up a process for each sandbox. And this model where we spin up a process and host functions per sandbox in that process. Mark, you have a question?
No, I'll wait till the end. This just
Okay.
reminded me I have some comments.
So I'm not going to dig too much into the code, but effectively I have a really simple example, and the main function just does some command line parsing, and this example allows me to effectively show those three scenarios that I talked about: in process, out of process, with a host function in the outer process, in the sandbox process. So mainly this code is partly to do with dealing with those options, but we'll just have a quick look at it. Effectively, we have a guest binary. In this model, I created a new crate for Hyperlight Mesh, so everything is built on top of existing Hyperlight. There's no changes really to existing Hyperlight. I had to move a few things around, but other than that, no real changes. I introduced a builder. I passed the guest binary to it, so this is, in this case, simple guest. On that builder, I have an option to say whether it runs in process or not, and the way that the option to run the sandbox process with host functions manifests itself is as basically a custom program that we build that's used as the host for the sandbox. So we can pass that in. And then it really does, I think it does three things. It calls a function in the guest. None of this code is any different than anything we already have. We basically create a return type, some arguments, and then call a function and get the result, and so on. So it calls a function in the guest. It calls a function in the guest that prints to the host. So it's basically calling a host function. And then finally, it creates a new sandbox, which has a guest function which calls back to a host function. Now, the important thing about that is that there are two implementations of that host function. One is in this program, because this program is our host, and then one is in our custom host for the sandbox. The one in here is literally an adder function that adds two numbers together. I'll show you the other one in a minute. So if we run this program, so is that big enough? Let's run this.
Looks okay.
Let's run this program. First of all, I'm just going to pass in an in-process flag of true. So this thing is just going to run pretty much as Hyperlight does today. Nothing really that interesting about that. You couldn't really tell any difference. We can also run this by saying run out of process, and you can't tell, but it did run out of process. I'll show you that in a second. And we can also run it out of process, but this time pass it the name of a program we want to use to actually host the sandbox, right? So we are passing in the name to a binary, and that binary is going to be spawned and is going to be the host for the sandbox each time we create a new sandbox, right? So we do that. Now notice that the return value for this is 25 and the return value for this is 15. We're passing the arguments 5 and 10 into our add function. I did that just so that it makes it easy to see which version of the host function is running. If we go and look into this mesh host program that I'm using, then you can see it's fairly simple, right? It's basically has this thing that I've called a registry for holding details of host functions. You define a host function exactly the same way as you would in a Hyperlight host today, and then you just run this sandbox mesh run host method. And notice that this host function adds 10 to the add, so hence we got 25, right? So in that third option, every time we created a sandbox, we're actually running this program to host the sandbox. Make sense so far? It's all a little bit difficult to explain very quickly. Let me try and prove to you that this is the case, right? So let's debug these things. I've got a few debugs configurations here. I've got one to launch Hyperlight Mesh in process, so let's do that. Right, so we've just stopped at the end here. This is the example program that I showed you that calls those three functions. If I go here and do you can see there's a single mesh program running, right? So the two sandboxes are still there because we haven't exited the function, so they've not been dropped yet. There's a single program running, so the sandboxes are running inside the host. Let's do this one, the sort of out of process, but I'm not providing a custom host for my sandboxes. So the second slide I showed, if you like, same thing. It's going to stop here. We're going to bring this up and we're going to do the exact same command we did before. There we go. Now there are three processes. So effectively this process has been forked, cloned, and there's now two additional processes that are actually hosting our sandbox. And then that third option where we're going to pass the name of a program to run as the host for the sandbox. Oh, dumb user error. And this time we have three processes again, but this time we have this mesh host process that's the host for each sandbox instance. Okay, so that's the end of the demo. The mesh framework a low level at least, has the capability of layering seccomp filters and a whole bunch of other constraints over the processes that are launched. And that is sort of the point of doing this. If you're thinking, why the hell would we want to do this? Well, one is isolation of host processes, but the other is so that we can constrain those processes in terms of what they're allowed to do. That is not shown in this demo, but and in fact, in the mesh framework isn't completely wired up right now, but that is something we will be able to do if we move forward with this implementation. Right, that's it. Done. 4
Yeah,
minutes
I was
left, I
gonna
think.
add another potential use case. I think that this could be extremely powerful for um, services that are hosting a lot of like Hyperlight instances where customers add in, like where customers uh, would give their like would run their workloads and their just potentially some of those host function calls could be relatively expensive operations, and I could imagine some sort of a essentially denial of service attack um, for something like that. And that actually reminded me. So in Kubernetes, there's the kubelet, which runs all of the workload containers. And the way it's structured is there's a C group that is set up for the kubelet, and then there's a C group that's set up for each pod. And pretty much since I've been involved in the project, there's a debate. Like in Kubernetes, there's things called like exec probes and liveness probes and readiness checks that you can configure in your pod spec, where they will go and periodically either do an exec call into the containers in that pod, or hit an HTTP endpoint or hit a gRPC endpoint. And there's been like a debate for the exec probes in particular, and for some of the other probes, where who should get charged for that? Should that be part of the kubelet C group or part of the pod C group? Because some pods may not have like any exec probes and may have very tight like memory usage or CPU usage limits, and other pods like may not too. So there's kind of been a debate like where should that get charged? And I think with this model, we could let whoever is running the hosting infrastructure kind of decide who would get charged, like charged in terms of like the CPU and like the CPU cycle count for that too. In addition to adding some security like over the C group, seccomp filters and things like that. I think it could also prevent some sort of like denial of service or noisy neighbor attack too. So super interesting.
Yeah, I think so. It's interesting. The hardest thing of all to do in this demo was the thing where to find a model where I could create a process, a custom process to host the sandbox. The rest of it was really quite straightforward. And it doesn't really change Hyperlight at all because it's sort of sitting on top. I mean, we could integrate more deeply if we wanted to, but we can equally just build this thing as an additional crate or additional library or something. Anyway, I'm done.
Cool. But I think very powerful for potentially for anybody who would be running Hyperlight themselves. And then a time check. We've got about 2.5 minutes before we get kicked off. I don't know if now might be a good time to kind of end it unless people have or James, go ahead.
Oh, James got a hand up.
Yeah, sorry. I just had a quick question. So does that mean the function that is the host function that got spawned in that second process, the third option that you showed, does that mean that host function is isolated from being able to do anything with the host?
It not really. It means that it's basically running in the same process that the sandbox is running in. So each sandbox is effectively isolated by process from host functions. So let's say there was some state associated with that host function and someone made a mistake of some description in the multi-hosted version. If you did that in that third version, then you're basically not going to be able to share state across tenants because they're all going to be in different processes.
Yeah, even in the host function.
Yeah.
Okay. Yeah, I guess that's kind of what I was getting at. I was like, that adds that extra a little bit of extra layer
Yeah.
there.
Yeah.
But
Yeah,
it
you
isn't
can
actually running inside a hypervisor. So if there is a
No.
bug, it could still access the rest of the host.
Yes. Yes.
you could also imagine wrapping that in a C group and giving it its own
Yeah.
root file system to that
Yeah.
Yeah.
the child process and have more of a security in depth kind of approach.
Deny inter-process communication between other.
Yeah.
Yeah.
Yeah, I think there's a ton of possibilities for it. And the overhead, I did benchmark it, and the overhead doesn't seem massive on the limited benchmarks that I did.
Cool.
So we'll
And I
have to
think
see.
I just got to pop up less than 1 minute left, so like I'm gonna stop the recording now too. Then. All right. See everybody around.
Bye bye.